relations, but linear inequalities. So that's how this is different. Okay. Graphing systems of linear inequalities, page 29. Okay, this is on page 29. We proceed the same way as before, but now you have multiple inequalities on the same pane. Some of you saying, yeah, it's a pane. It's a pane. This unit is a pane. You must work with each, right? I don't know if must work. It's a bit harsh. You can do whatever you want, but I suggest you work with each separately to make sure you don't mix up your solution regions. I would strongly advise against doing them all at the same time, working with all of them at the same time. Just do one at a time. Shading systems. This is very important here. When you have a system, okay, having multiple solution regions makes it difficult to determine the solution region for all inequalities. To make it easier, this is what I want you to highlight. To make it easier, this highlighter has seen better days. Try again with this one. To make it easier to determine the overall solution region, we use reverse shading with systems. It's not like you're going to get marks deducted if you use regular, but it's going to be very difficult and you may make a mistake as a result. In essence, we shade out the false regions, and the area left unshaded is the solution region. Okay, so this is me using regular shading. And guess what would be the solution region here? Can you tell? It's going to be the darkest region of them all. That's where all of them overlap, right? All of them get some sort of shading, and in this case, they all overlap here, every single one. All three of them, there's three here. They overlap. So this is my solution region. However, this was done with software. You're not going to be that as you say, I'm going to shade a little lighter here, a little darker there, because there's different colors that appear. So to account for that, I use reverse shading instead, okay, where this is my solution region here. All of this is false, 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 right? So you basically get rid of all the false regions. It can't be this, can't be this, can't be that. It has to be whatever isn't shaded. That ends up being the true region for all of them. Okay? So the solution region is there. By the way, both of these, regardless of which method you choose, this is still the solution region. Okay? For both of these, that doesn't change. Where the true area is doesn't change. It just makes it a lot easier. To me, this was such a no-brainer to go with reverse because it makes it easier to shade. Okay, let's keep going. Points of intersection or corner points. The points where boundary lines meet, that's important. What are POIs, or points of intersections? Are the points where the boundary lines meet the surrounding solution region. Okay. So you've got, in this case, if this is your solution, it's copy-paste of the boundary lines meet here, the boundary lines meet here, and here. Okay. So you've got 3 POIs. That one, and this one. And to give you another example, over here you've got 2 inequalities, right? And obviously we're using reverse shading here. So this is your solution region. How many points of intersection? This is your solution region. There's one here, and you might think there's another one maybe here. No, this is the x-axis, so don't be confusing that. This solution region gets bigger and bigger all the way to infinity, right? So there's only one POI here in this case. And how do you know? Well, this is the only point where the boundary lines meet, right? They don't meet anywhere else. So there's only one POI. So this is just kind of making sure you understand the concepts before we dig in and graph these things. Okay, let's go to page 30 and try one. We'll start with 2 only at first, and then we'll do 3 at a time, right? So to not make it too overwhelming for you. So let's go to 30. And I picked the setting, the notation here, the way it's set up, just to get you used to it in case you ever encounter that. So first of all, graph the following system of inequalities, then identify the solution region on the graph. Include POIs. So that's going to be at the very end what you're going to do. It is a good idea to graph all lines on the calculator. I highlight that part. It's a good idea to graph all lines on the calculator before graphing on paper. Why is that? The POIs may not be, be outside your grid if you don't do that. You might be graphing and say, oh yeah, cool. Let's find the POI. Whoa, it's outside my current grid. Like I need to change my scale to make it fit. Okay. Okay, let's look at this. There are 2 inequalities here. Okay, this is inequality 1. This is inequality 2, or AB, whatever you want to say here. And this notation is also a set notation. It's saying that the variables in this case are x and y. This is right here, I'm going to highlight that part. This is the inequality presented to you. Same down here. That's really what we're going to work with. But it's saying that for both of these, x could be all real numbers, y could be all real numbers for both of these inequalities. It's just saying everything goes. Okay, there's no restriction on that. So don't let that throw you off. It's just a way of presenting it. So let's work with inequality 1 here first. I give you space, so you just use that space any which way you want. Anywhere on this paper. If this is a test or an exam, just make sure it shows up on this paper and you clearly label what you're doing. So let's look at this one here. 4x is greater than 6y plus 12. This isn't quite the way I want it because I want to find the intercepts. Okay, so I'm going to go like this. 4x, what happens to the 6y when it comes over? Subtracting, right? Is greater than 12. 12 stays on the right side, so no sign change. And the reason you want your intercepts is because you want to graph it, and that is the best way to do it. Trust me, later on when we do word problems, this is the way to do it. It's the best method. So for x-intercept, it's just 4x is equal to 12. I treat this as if it's a linear equation. Just for this part right here. Remember, just for this part. 4, divide everything by 4. X is equal to 3. Our x-intercept is 3, 0. Okay, now your y-intercept. I'm using this one here. Negative 6y is equal to 12. Divide both sides by negative 6. Y is equal to negative 2. So 0, negative 2. Boom, I've got that. And normally what I do, either beside this or underneath, it depends on my space, I rewrite this thing, okay? Why would I rewrite it? Because I'm going to end up entering into my calculator and I want to know where to shade. So let's rewrite this one. So it's going to be negative 6y is greater than what comes over the 4x, correct? When the 4x comes over, it subtracts. The 12 is already on that side. I'm just going to leave it like that. Alert, alert, what's going to happen now? What do I need to divide both sides by? -6, right? You heard that? -6. So alert. You're going to flip the sign. Okay, I will do that first. Flip it and then just say y. -4 divided by -6 is just 4/6. And I know some of you are saying, aren't you going to reduce that? You can if you want. It doesn't, you're not going to lose marks if you don't reduce. 12 divided by -6 is -2. This now tells us that it's going to be a dashed line. Where's the true region? This is important, this part. True is below, correct? Where are we going to shade if you use reverse shading? All right, you got that right. So watch this. Make sure you tell yourself that here. You don't want to guess later on, come back to this on where is it again? You tell yourself this, like I'm going to shade because it's reverse. You're literally shading the opposite of where the true region is. Okay? I got all of this from this part right here. So let's do the second inequality over here. I think it's going to work out if we do that here. Inequality 2. There it is. 3y is less than or equal to -2x plus 9. It's not quite the way I want it for x-intercept, y-intercept purposes. Some of you might say, why don't we just divide it by 3 right away and get it over with? We have the rewritten form. If you want to do that, go for it. I'm just going to bring the 2x over this side. So it's 2x plus 3y. Why is it positive 2x, guys? It came over, yeah. You got to make sure you get that right. 9 there. And I'm going to find the intercepts real quick. Okay, I'm going to say something. Yes, be quick with this, but not too quick. Because if you make a mistake on your intercepts, even the sign, it's going to be a completely different graph, and you're going to be frustrated. So it's 2x is equal to 9. You've done a lot of this in IAPR, I'm sure of that. Here it's okay to get a decimal answer, because you're just using this to plot this on your graph. So you kind of want a decimal, if it's not a whole number, of course. Then it's 3y is equal to 9. Hopefully I don't make a mistake like yesterday with that. That was pretty bad, eh? You'll forever remember that. Okay. So you've got your intercepts, good. You need that for graphing. I'm going to rewrite this so you can do it underneath. Or maybe, you know what? We have room. Rewrite. Let's do it right next to it. So I'm going to keep the 3y on the left side. The 2x is going to come over again, subtracting. And the 9 is already there. I divide by 3, which is not an alert because it's not negative. So it's just -2 divided by 3 is -2/3 x. 9 divided by 3 is just 3. And here's the important part. Solid, correct? Because of the equal sign. Solid. Where's the true region? It's below. Yeah. I'm going to S above. Shade. My answer key doesn't write it out, just so you know. It just says S, T, and then S above or below. Does it make sense that it's the opposite of where the true region is? I hope that doesn't throw you off, because some students are like, Mr. Dixon, what should I do here? The answer is you do whatever you need to do. I choose reverse shading, and I would strongly encourage that. But some of you are rebels, and that's okay. Be a rebel. Okay, so we got the shading. I'm going to circle the shading because that's important when I graph. Okay, so let's go ahead and graph these one at a time. So what do you have here? Oh, Mr. Dixon gave me a grid, but remember, you still have to do a little bit of work. That's, come on, right? X, Y. Before I graph, actually, let's put this in our calculator. We're going to put, I'm going to highlight the two equations, right? This one and this one. You want that in the calculator right now. So let's go ahead and do that. If a standard window allows us to see everything, then we're good. We're not going to bother with scaling it differently. -2/3 x plus 3. Don't forget the variable x, because if you don't, you'll get a horizontal line. You don't want that. Hit graph. Perfect. Look, it's very close to the origin. We don't have to worry about the POI being outside of our grid. So this is what you expect. If everything goes well, this is what you expect your graph to look like. So let's go ahead and plot it. First line right here. 3, 0, 0, -2. So let's just put some scale on here. I'm just going to count every box as 1. That's going to do it. I already gave you a grid, so just do a little bit more work and make it look legit. Okay? 3, 0 is right here. 0, -2 is right there. Sketch that line. Look here. It says dashed. So I'm going to make a dashed line. Dashed line. I will label it right away at the end here. Use a label that's going to help you, right? So I'm gonna use the rewritten form. And then the next one. The next one calls for 4.5. 4.5 is right here. 0, 3. It's right there. And this one calls for solid. Solid. So I'm going to connect those two using a solid line. So any points on this line would be acceptable. And then label it as well. And now the shading part. Make sure you have the lines down before you copy. This is my first line right here. I'm going to put my ruler there. It says to shade above that one, correct? So you just go right against it and you shade everything above it. This is all false for this inequality. Okay. And my second line, which is this one, it says the same. We concluded the same here. Shade above. That's what it says. So we're going to shade above that line. All of that is false for that inequality. Okay. So what are you left with? The solution region right here. Make sure you label that, because if someone that isn't in this course were to look at that, they would probably think this is the solution region because this is the darkest. Right? So you have to tell your audience this is the solution region. Okay? Have we done everything we needed to? Oh, the points of intersection. We're going to find that right here. Okay. Y1 has inequality 1 in it. Y2 has inequality 2 in it. And then we're going to go second, trace, intersect. Let's go ahead and find that. I already have it in there, so I'm just going to go second trace 5, enter, enter, enter. If you only have 2 lines, no big deal. It's 3.75, 0.5. And how about this? I'm just going to say that that's the point of intersection right there. Okay, that's it. Now, one last thing. Is 4, 5, is that point 4, 5? Is that a solution to the system? Where is it? 4, 5 is like over here. It's not inside the solution region, so we know it's not. But I will ask you this without giving you a graph, right? So what do you think you'd have to do with this? Plug them in. Plug them into both of these. Use the original, right? Plug them into both of these, and what are we looking for? Both of them being true. If one of them is false, you're done. You don't have to continue your work actually. So sometimes it's a little bit of a guessing game, which one should I pick first? But as soon as you notice that it's not true, you're done. So let's do that. 4x is greater than 6y plus 12. X is 4, right? So we're going to go 4 times 4 is greater than 6 times 5 plus 12. So 4 times 4 is 16. On the other side, you have 30 plus 12. It's 42. That is false, correct? Therefore, not a solution. I will do that for the other one, because let's say this had been true, then you would have had to continue your journey. So I'll just see here, 3y is less than or equal to negative 2x plus 9. Watch this, you have to be careful. The y is here, so 5, 3 times 5 is less than or equal to negative 2 times 4 plus 9. That's 15 is less than or equal to, this is negative 8 plus 1. Sorry, negative 8 plus 9 is 1. This is also false. But it's at the same time, you're still concluding not a solution. Note, all inequalities have to be true for it to be a solution. All inequalities, not just one. Okay, what else can come your way? Mr. Lewison, could I have a special case in there? Yeah, you could have a vertical line and a diagonal. You could have a horizontal line and a diagonal. You could have a vertical and a horizontal. So you know how to graph at this point, just go with it and treat each separately at first and then put them both at the same graph, okay? So I'm gonna say pages 31 to 33, okay? So I'm just gonna go to 30, I'll put it down here. There's one, you know what? I never told you the secret of drawing vertical lines. So I'll tell you on the next page. I found out, I Googled it, and someone came up with this hack, okay? I used to believe that you just couldn't, but obviously there's always someone smarter out there that will tell you otherwise. So on page 31, let's use this. I would add this to my study sheet. To graph vertical lines, we go y is equal to, watch this, you have to enter 9 nines. Don't ask me why. Okay. And then you have to go x minus whatever the x-intercept is. Question, if my x-intercept is -4, what would you enter into your calculator? X minus -4, what does that turn into? +4. So that you literally have to go the opposite of the sign of your x-intercept. Let's try that together once. I'm just going to leave what I have. I'm just going to go to y3 and just go 1, 2, 3, 4, 5, 6, 7, 8, 9. X, let's say you want x to go through +3 vertically. Then I would go -3 like that. Close it. And then hit graph. You see that? Right? It goes through +3. If you change this to +3, if you go change that to +3, it's actually going to go through -3. So it's always the opposite of where you want it to go. Watch this, right? Now the vertical is on the left side. How is this going to be helpful? Because some of the boundary lines are going to be vertical. And if you want to find the points of intersections later, you can use that just like you would the functions before. All right, and by the way, there's a vertical on that one. On page 31, there is one there. Okay, I'll leave you to it. Make sure you use your time wisely, because you can ask me questions if you're stuck. I will try to post the key. I'll find it and post it. So if you want to check right away, you go for it.